Hello students. In this video we will start with the chapter lenses. Now you must have seen lenses which are used in day-to-day life. Some example of lenses will be the lenses used by old person for reading, lenses embedded in the front door of the house, the lenses which a watchmaker attaches to his eyes. So we have also seen the lenses which are used in spectacles. So at all these places we use lenses. Even in telescope we use lenses. So now what is a lens? So a lens is a transparent medium which is bound by two surfaces. The lens which has two spherical surfaces and which are puffed up outwards is called as a convex or a double convex lens. And this lens is thicker near the center as compared to the edges, as you can see in the figure here. Now the lens with both surfaces spherical on the inside is called as a concave or a double concave lens, and this lens is thinner at the center as compared to its edges. Let us learn more about these lenses. So we saw the different types of lenses. A ray of light gets refracted twice while passing through a lens, once while entering the lens and once while emerging from the lens. So the direction of the ray changes because of these refraction, and both the surface of most of the lenses are part of a sphere, and so it is called as a spherical lens. Now to understand more about lenses, here in the figure the cross sections of convex and concave lenses are shown. The surface marked as 1 is part of the sphere S1, and while the surface which is marked as 2 is the part of the sphere S2. Let us see more about these surfaces, like what will be the center of curvature, what will be the radius of curvature, and all those things. So first of all, let's talk about the center of curvature, which is C. So the center of the spheres whose part from the surfaces of the lens are called as the center of curvature, and here in both the spherical lenses we can see it is marked as C1 and C2. So these are the center of curvatures. Next we have the radii of curvature or the radius of curvature, which is R. So the radii, here we can see R1 and R2, and they form the radius in the entire circle, and so it is called as the radius of curvature. Next we have the principal axis. So the imaginary line which is passing through both the centers of the curvature is called as the principal axis. Next we have the optical center, which is O. Now here you can see in both the figures optical center O is given. So the point inside a lens on the principal axis, the line which is the imaginary line that you can see, through which light passes without changing their path, is called as the optical center, that is O. Next we have the principal focus. Now what is principal focus is when light ray parallel to the principal axis, they are incident on a convex lens. They converge, all of them will converge to a point of the principal axis, and then the converging point becomes your focus, that is the principal focus. Next we have the focal length, that is denoted by small f, and here in the figure you can see that it is the distance between the optical center and the principal focus, and this is called as the f. So here in both the figures you can see in first there is a small f which is outside, which is the convergent, and next we can see in the divergent lens it is shown towards the end, that is the small f, and this is called as the focal length. So whenever you are calculating the focal length, you have to calculate the distance between O and the principal focus, that is f. So when we draw a ray diagram for a convex lens, there are few rules through which the incident or the refracted ray will be passing. So rule number one is that when the incident ray is parallel to our principal axis, so you can see in the diagram the incident ray is parallel to the principal axis. So the refracted ray will pass through the principal focus. So you can see it is passing through F2. So it is parallel to the principal axis, it will pass through the focus. Then next rule, that is the second rule, is that when the incident ray passes through the principal focus, so then the refracted ray is parallel to the principal axis. So as you can see, it is passing through the focus 1, and then next when it gets refracted, it is parallel to the next, that is principal axis. Third rule is that when the incident ray passes through the optical center, that is our O, so the passes the ray which will be passing, which it will have no change in the direction. So the way it is going, it will emerge in that direction only. So when the incident ray passes through the optical center of the lens, so it passes without changing its direction. So these are the three rules that is we have to follow when we draw any type of ray diagram for convex lens. Let us understand what is a real image of a convex lens and a virtual image. So, as here in the figure it is shown, an object AB is placed, and this is placed beyond the point 2F1, that is our focus 1. So, the incident ray BC, you can see there blue color it is shown. It is starting from B and going parallel to the principal axis, and then it goes through the principal focus F2 and it gets refracted along the line C and T. So BC is the incident ray and CT is the refracted ray here. Now the ray BO, starting from B and passing through the optical center O of the lens, and it goes along the OS without changing its direction because it is passing from O. The second ray goes without changing its direction. It intersects CT, as you can see, both are getting joined together at a point that is B dash. So this means that the image of B is formed at B dash. Okay. So as A is situated on the principal axis, so its image will also be located along the principal axis at A dash only, which will be vertically above B dash. So AB dash will be the image of AB formed by the lens. So from this we can say that if an object is placed at 2F1, the image is formed between F2 and 2F2, and it will be a real image, and also as it is formed beyond the lens, and also the image which is formed is inverted, so it will be a real and it will be an inverted image, and the size of the image will also get reduced and our size will become smaller. So this is how you come to know whether the image is formed. If it is formed in the opposite direction, it is a real image. If it is formed in the same side of your where the reflection is happening, then it becomes a virtual image. And as here we can see that an inverted image is formed, it is a real image, and also that the size of your image will get reduced. So any object which is there on the other side of the lens and he is looking at something, so that image will get inverted when you see through the lens, and also it will be a real image. So if someone asks you when can a real image or a virtual image can be formed, so a real image can be formed when the position of the image is on the other side of the lens, and when the position of the image is on the same side of the lens, then it is called as a virtual image. So these are the two things between real image and virtual image. Let us now look at few of these ray diagrams when you keep the object at different places and what type of image is being formed. So here are the images formed by the convex lens, and these are for different positions of the object. So for example, when you keep the position of the object at infinity, like a very far away, so the position of image which will be formed, that will be at the focus, and very point image, very minute image will be seen. The size will be very minute. It will be real and inverted, as we have talked in the earlier slide. Next is when it is kept on 2f2, the image will be formed smaller, real and inverted. Maximum it is formed, real and inverted images are only formed only when we keep the object at f1, between f1 and o. Then a very large and a virtual and erect image is formed. That is the image, the position of the image which will be there, it will be on the same side of the lens as that of the object, and because of which virtual and the erect image is formed. Let us look at the ray diagrams so that we can understand in a better way. So as in the first case, we can see the object when it is kept at infinity. So the position of the image which is formed, that was on f2. Okay, you can see in the first one. And the size of the image will be very small, and it will be real and an inverted image. Second case is when you keep the object beyond 2f1, that is outside 2f1. So again there is reflection which is happening between, that is AC is the incident ray, then C and A is the refracted ray, then again it is passing from O, and then when they meet together, so that is between the position where they are meeting, that is between f2 and 2f2. So the image is smaller and it is again real and inverted. Next is the third scenario, that when you keep an object at your focus 1, that is 2f1. So when we keep the object at 2f1, you can see A and A and B is the image which is the object which is kept. Again after reflection, A dash and B dash is our image, and the position of the image is at 2f2. It is almost of the same size as AB. So AB will be almost same size as A dash B dash, and again it will be a real and inverted image. Fourth one is when we keep the object between f1 and 2f1. So you can see the refracted ray and the incident ray and the refracted ray, they meet together at A dash and B dash. So you can, as from the diagram only, you can see that the image which is formed, it is very large, it is real, and it is an inverted image. Fifth case is that when you keep your object at f1, so A and B is our object and we have kept it at f1. So the position of the image that will be formed, it will be at infinity, it will be joining at very far away. The image, the size which will be formed of the image, that will be very large, and again it will be a real and an inverted image. Next, we have the sixth scenario, that is when you keep your object between f1 and o. Now, as you can see, AB is also present on the same side, and after refraction, the position of the image which has been formed, that is also on the same side. So AB is also present on the same side, and A dash and B dash is also present on the same side. So we can say from this that when you keep an object at f1 and o, between f1 and o, so the image which is formed, it is formed on the same side of the lens, and also it is a very large image, and it is virtual and an erect image. It is not inverted, it will be an erect image. The images which are formed by a concave lens. So very few images are formed with the help of concave lenses. So as you can see in the figure, the object PQ is placed between f1 and 2f1, which is in front of a concave lens. Now there is an incident ray, that is PA, which is starting from P, and it is going parallel to the principal axis and goes along AD after refraction. So if AD, we can say, is the extended backward, if we extend AD backwards, so it appears to come from F1. The incident ray PO starting from P and passing through O goes along the same direction after refraction, and PO will intersect the extended ray AF1 at P1, that is P dash. So P dash is the image of P. As this we can say that. So as the point Q is on the principal axis, so its image formed along the axis at the point Q dash is directly below the P dash. So we can say that P dash and Q dash is the image of PQ. Now as you can see from this ray diagram, the image which is formed, it is with the help of concave lens, and always whenever the image will be formed with the help of concave lens, it will be always virtual, it will be erect, and it will always be smaller than the object. Okay, so this is the main thing that you have to remember. Let us understand the ray diagrams for concave lens. So we can say only two ray diagrams are here. That is when you keep the position of the object at infinity, or you can keep it anywhere between the O and your infinity. So first is when you keep the object at infinity. So the position of the image which is formed, it is always at the focus 1. It will be a very minute image that will be formed, and as we know, in concave lenses only virtual and erect images can be formed. Next is when you keep it between O and infinity. So your position of image will always be between the optical center, that is O, and your F1. The image will be smaller in size, and again it will be virtual and an erect image.